Welcome back to Advent of Code and Random Programming Languages. This is day 3. We just finished Elixir on day 2, in which I forgot about the pipe operator. I'm sorry about that, but that's okay. If we get F sharp, I can still use the pipe operator, so there's some hope remaining for the pipe operator. But we have no idea what we're going to get today. I'm hoping for something quick. I don't have much time today, so we'll see how much we do. I might have to split it into like a cut in the middle, depending on what happens, but we'll see. But we are going in with different languages, so let's do it real quick. And we are going to shuffle our languages. Lots of options. Hopefully we don't get something like functional, I don't know. Odin, okay, yeah, Odin's good. Let's do Odin. All right, day 03. We're gonna have input, test input, part 1.odin and part 2.odin. I have never programmed in Odin before. I do know that this is the file extension though. Let's see. Learn Odin learn y in x and just learn x and y. And we also want the compiler. Yes. Odin. And what I understand from Odin is that it's a very productivity focused language. This is a language that I've actually been considering for one of my projects, although I think I'm just gonna stick to C for it. I'm not super confident that Odin is better than C to me. Okay. So can I run a single file? Odin run single file. Because I know that it's set up as directories. Odin run single file. Because I think there was a way to do this. From source. Okay, the overview is what I want. Yeah, you can dash file and then run it like this. With run, right? It has to be after. Okay, that's fine though. And then we have to define the main procedure, which is fine. So we will have main procedure. Is there a main? No, I don't have anything for this language in my editor. That's fine. Print line hello, and that is the way that it's done in this language. Optional semicolons, import core fmt, and this is the package main. Does it need to be declared as the package main? Yes, every file needs a package declaration. Okay. If I remember correctly, though, everything in the same directory needs the same declaration. But there you go. So there's hello. That was fairly quick. And then we can also run part 2 and it won't run part 1, right? Yes. So they can be different things. All right. So that feels fairly good. I like that it's the I like the symbol for it. Odin dev 2510. It's like the Nordic O accent. Very nice. Okay, so yeah, we have Hello World. And I'm pretty confident that I can just write Odin pretty confidently. And I don't have to worry about... Does it have the same like constant declaration that's in Jai? Yeah, it does. Okay. No, it's like this, and then like colon equals assignment equal. Yeah, yeah. Okay, cool. Or a typed inferred. Yeah. And this is declaring a variable main, which is a procedure, which is kind of nice. And I believe arguments go in here. Let's see. Procedures. Yeah, and it's procedure colon type and return with an arrow. Awesome. Okay, I feel pretty confident about all of this. So let's see our problem. Day 3. You descend a short staircase, enter a surprisingly fast lobby, and are quickly cleared by the security checkpoint. When you get to the main elevator, however, you discover that each one has a red light above it. They're all offline. Sorry about that, and Elf apologizes as she tinkers with a nearby control panel. Some kind of electrical surge seems to have fried them. I'll try to get them online soon. You explain your need to get further underground. Well, you could at least take the escalator down to the printing department. Not that you'd get much further than without the elevator working. That is, you could find if the escalator weren't also offline. But don't worry, it's not fried, it just needs power. Maybe you can get it running while I keep working on the elevators. These are the batteries nearby that can supply emergency power to the escalator for just such an occasion. The batteries are each labeled with their joltage rating, a value from 1 to 9. It's like jolly voltage. You make a note of their joltage ratings, your puzzle input. For example, okay, a bunch of batteries, all whatever. They are arranged into banks. Each line of digits in your input corresponds to a single bank of batteries. Within each bank, you need to turn on exactly 2 batteries. The joltage that the bank produces is equal to the number formed by the digits on the batteries you've turned on. For example, if you have a bank line of 1, 2, 3, 4, 5, and you turn on batteries 2 and 4, the bank would produce 24 jolts. You cannot rearrange batteries. You'll need to find the largest possible joltage each bank can produce. In the above example, 9, 8, 8, 9, 7, 8, 9, 2. Okay, so unless the largest one is on the end, the largest one should come first. Well, first let's try to get our input in. So let's figure out how to open a file. Oh, that's not test input. Or that is test input, not input. And then we'll get our puzzle input. Okay, it's 200 lines long. Makes sense. So let's see how we should get this. So we have a hello world, basically. And all right, so we need to open a file. Let's figure that out. So Odin files. Odin language files. Is there not like, I guess it's examples? I mean, strings would be good, probably, to look at. But where's like the documentation for anything? Is it too young of a language to have good docs on anything? Because that would be unfortunate. File IO in Odin language. Reading a file line by line. There we go. So import core OS and core strings. I think we're going to need both. Really, there's not just a... Okay, whatever. We will just do this. So data okay is os.read entire file path. Oh no, that's fine. Okay. No, that's actually totally fine. And the file path is just going to be test input. And then we should be able to just like io dot, or what was it, fmt dot print line data. Okay, awesome. It gives you bytes of data though, of which are I believe those are Unicode characters. Yes, so you have to string the data. So string data, and now we get the string. Okay, yeah. That's totally fine. So let's do split lines iterator. Okay. So for line, so it colon equals string of data for line in strings dot split lines iterator it. We'll keep this formatting. That's fine. It's not really how I format C code, but that is okay. And then we have lines, so then we could say like fmt dot print line, and surely that will, yes, that will give us each line. Cool. So we don't really need anything else from here. So Odin string functions, or procedures, I guess. Package strings. Okay, so it's in package. Okay, so packages has the core library. Yeah, okay. So we have a string builder, we have a string ASCII set. This is types, we don't care about types. Where's procedures? Okay. Do we have, so I mean, we already split by what we want. Do we have like iterate or something? Or is it already, like, can we say like for num in line, and then print the number? Yeah, we can do that. Okay, excellent. So on each line, so first we're gonna want a sum, and that sum is going to be counting up this, right? So we want a sum that counts the total output joltage. Or here, I'll call it joltage even. Joltage. So joltage is colon equals 0. And then we are going to joltage plus equals battery. Right, and battery is gonna colon equals 0 here. And then we're going to print joltage. And battery is going to basically count up for this. So for number in line, we are going to have a max value. So we can use battery for now. And this should not be added every time. Well, I guess it should be added at the end. So battery, this isn't the right thing. So current like max should be 0. We don't care about min. We care about max 2 or something akin to that. So what is the edge case exactly? I guess if we work, wait, let's see, if we iterate it backwards. It doesn't really matter. It's just whether we choose the first or we choose the last as a special case then. So let's go forwards, and we're going to search for the maximum, and then the second most that is right of the maximum. So yes. So for num, so there's going to be like max 2, which equals 0. So if num is greater than max, is there a single line? Maybe not. I feel like this language is opinionated enough. Maybe there isn't. But yeah, let's just do this. If num is greater than max, max equals num. And then max 2 resets to 0 in the case that we find something. And this is only if we're not on the last character. So if num or is there a way to check an iterator like that or something? I don't know. Can we just do a for, like a standard C for loop? Yes, you can. So for I equals 0, I less than it.len or something. Let's see, what is the type of a string? Is there like actually just a string? What is the type of a string? Well, let's just try to run it. Okay, well, yes, but, and let me guess, there's no, yes, there's no that operator. Has no field to len. Okay, how about length? Has no field length. How about size? Does not have field size. Okay. Odin string type. Okay, you have to call len on it. That's weird. It's not like a struct. Very strange. And now there's no num. So instead of num, we say it at I, it at I. Wait, why am I doing it? Line at I. And that's not going to work because it's not an int, so we have to parse int. Odin parse int. Strconv. A to I, yeah. So it returns an int. Value equals a to I of line I. What is this? Stir convert. Oh, I see. I have to do it like that. Okay, I'm just going to do this the old-fashioned way. Int cast, I remember casts look weird in this language too. Yeah, it's like that. Int of, oh no, that's a bitwise not. Yeah, it's like this. It's the parentheses are opposite of C. So we're doing int we're doing int, and I guess I should just do it like this, right? Put this into an int, the value of line at I minus 0. Expected a type, got a new line. How do you declare a variable? Yeah, it's exactly like this. Oh, why is this? I don't know why I put that there, but surely this works, right? Yeah. Can I assign value u8 to int? Yeah. So I'm gonna cast the solution of this to an int. Index 15 is out of range, 0 to 15. Off by 1 error. Really? There's a better way to do this loop anyway. Loop. Why is it? Why is it doing that? Range based. Yeah, okay, so we can do it like I is 0 dot dot less than len of it for I in that. It still doesn't like that, yeah. I mean, it's the same thing. I don't know why it wouldn't be. But I'm confused. So it's on line 1731. Yeah, accessing int of I. Or line of I. Oh, because I'm, yeah. Okay, I don't know why I'm doing that. Okay, 0, and that's because we're not incrementing joltage by anything. So this is if I does not equal, it's going to be and at the end. This is if I is not len of line minus 1. What? What am I doing? There we go. Okay. So this runs fine. And then what if we just print line max every time? So here's the max on every, okay, actually print max there. So the max is 9, 8, because we're not counting this 9, and then 7, and then 9. Okay. So then, whenever we assign a new max, we're also going to check. So if this didn't work, then we are going to say else if max 2, if value is more than max 2, then max 2 equals value. And then if we print line like this, assuming we have variadic args, which of course we do because, I don't know, but Elixir didn't have that for some reason. And we get 9, 8, 8, 9, 7, 8, 9, 2. Okay, awesome. The algorithm works. And now we just voltage plus equals max times 10 plus max 2. And we print out our final answer. It's 357. Awesome. And now we run that on the super one, the real input. I'm pretty confident in this one, so hopefully we're good. It runs really fast too, which of course we're happy about. And that is correct. Awesome. That was pretty fast. Definitely working with C-like languages is my preferred mode anyway, so that makes sense. Okay. So part 2, the escalator doesn't move. The elf explains that it probably needs more joltage to overcome static friction. And this is the Wikipedia page for static friction. Nice. Of the system, and hits the big red joltage limit safety override button. You lose count of the number of times she needs to confirm yes, I'm sure, and decorate the lobby a bit while you wait. Now you need to make the largest joltage by turning on exactly 12 batteries within each bank. The joltage output for the bank is still the number formed by the digits of the batteries you've turned on. The only difference is that now there will be 12 digits in each bank's joltage output instead of 2. Consider again the example from before. Now the joltages are much larger. The largest joltage can be found by turning on everything except some ones at the end to produce big number. In the digit sequence this, the largest joltage can be found by turning on everything except some ones producing this. In this, the largest joltage can be found by turning on everything except a 2 battery, a 3 battery, and another 2 battery near the start. And in this one, okay, so the question is, are they all constant length? Okay, they're really long. They're all 100 characters long, but they are of constant length, so they're all 100 long. But we're turning on 12. So I was thinking maybe we find the minimums with the test input. That makes sense, I think, because you're only turning off 3. But in the real one where you have 100, that doesn't make sense. So this is going to be some kind of stack or queue problem, like a max heap or something like that, like something that's organized so that the max always ends up in the same place. I think that makes sense. All right. Let's do... So I guess the real trick is to put in the first 12 into an array and keep track of the minimum of that array and its index. And then anytime you encounter a new number which is larger than the minimum that's currently in the array, you put it in. But you have to keep the order as well. So it's not actually an array, maybe it's like some kind of linked list type structure or something. I think that makes sense. Like a... Yeah, I think the linked list kind of makes sense. Or you store it as an array and you store each thing in the array with its index in a struct, and then you rebuild it at the end with the indices from smallest to largest. That could also work. Let's do the first solution. I think the linked list solution is pretty easy. Let's see, does Odin have like a linked list built in? I don't think it has any kind of generics or anything. There is a package container intrusive list. An intrusive doubly linked list requires a node to be embedded in your own structure, like this. Okay. So, here's a full example. List.pushback and okay. Let's try this. So this is gonna be, we're gonna write this as part2.odin as well, and then we're gonna go into part 2 and we're gonna compile part 2. It's gonna complain about no main. Wait, really? Oh, I did the same thing I did last time. Day 2, day 3, paste, delete that one. Yes, go in. There we go. And now it will run. Yes. Okay. So let's try this. Let's import container intrusive list. Let's see, what else is in container? We have bit array, intrusive list, least, what is this? Least recently used cache. Oh wait, actually could be useful, but I don't think in this case. Priority queue. Okay. Queue. Right balance, or a red black tree. Okay. Small array. A dynamic array-like interface on a stack allocated fixed size array. A container for a fixed number of elements of a specific type with a total number known at compile time, but the exact number to be used determined at runtime. Interesting. And topological sort. Okay. I think we're fine with the list though. So the list is a linked list, right? Yes, it's a doubly linked list. So assumably we can remove things. We can remove, yeah, we can remove. Removes an element from the list with O of one-time complexity. That is exactly what we want for this kind of solution where we're going through and changing everything out. We could also do an array with a bunch of holes in it, but pretty much the same idea. And honestly, I've been enjoying linked lists recently. I've been a bit of a linked list enjoyer. Because I think like linked lists are actually not as slow as you think. You always think pointer, I have to go to main memory, it's slow. But if you allocate, like if you build your whole linked list all at the same time, your entire linked list is going to be in L1 cache. And then getting the pointer from L1 cache is like one instruction, which is basically the same cost as going through, like going through an iterator on an array is basically the same speed as fetching a pointer from L1 cache. It's not exactly the same, I mean, but it depends. Like, it's not that much slower, is my point. So, if you know that you have good cache locality on your linked list, I think linked lists are, like, pretty fast. So, let's do that. Let's, so here, instead of the max and the min, we don't care about that anymore. We do kind of, well, the battery was stupid in this one, too. We never used it, right? Yeah, it was an unused variable. Just to confirm that's true. Yeah, that's true. Okay. Yes, it was an unused variable. What's it mad about? Path does not exist. Oh, it's core. There we go. Yeah, it's because I just got rid of max. So let's figure this out now. So we're iterating through this. So at the start of a line, we're going to allocate a new list. So it's like a capital L list dot list, right? Oh no, it's the other way around. List.list, there we go. And then so you have to push back .node. Okay, and I'm guessing like basic types don't have this, right? List. Remove. Yeah, so I'm gonna have to make a node type or my own like digit struct with a node, which is a list.node, and a value, which is going to be an int, right? Or I guess, can you declare int in a struct? Type of variable L cannot be inferred as a type and does not have a default type. I feel like that might happen when I use it later, though. At least judging by the fact that it was used very freely here. Oh, but it's because I did colon equals. I should have just done colon list. Yeah, there we go. So L is a list. And then we can say for I. So if L dot size or whatever, let's see, procedures, it's not going to be L dot size because does it not keep track of its size? List. It doesn't? That's kind of yucky. The linked list I use in C, I always put a size, like a length element in it, which is just really useful. I mean, technically a tiny bit inefficient or whatever, but really, I don't want to iterate the entire linked list just to get the size. Okay, whatever, I'll just have my own size 0, and then we can if L dot size is less than 12, less than or equal to 12, right? Because we want size 0, we add 1, size 2, we add 1, you know, size 12, we don't add 1. Okay, yeah, so maybe if it's less than 12, yeah, okay. I'm just being dumb. If it is, then let's say that we're going to insert it into the list. So that means a list.pushback L and a reference to, oh, do you, okay. How does this work? Does pushback allocate, does it copy and allocate? Like this is, it's not contextless. So assumably this needs to be heap allocated. Okay. So allocator, I guess. Yeah, I don't really understand. Oh, and apparently I got rid of my code that interprets the value. We're definitely still going to want the value. We're always going to want the value. So we would push back value like that. The problem is that's not going to work. Is it actually going to catch it? Okay, also true here. So what we actually want is digit value equals value. Wait, what? It's running part 1. Okay, yeah, you don't do that. You do this. Cannot assign digit, yeah, dot node. There we go. So this kind of works. And the problem with this is I'm pretty sure, I mean, if this is C, which is a C-like language, this is being destroyed and then it references null after every loop iteration. So we need to allocate this. So allocation in Odin. Let's see, package mem. Okay, so there is a mem package. We don't need to worry about deallocating. We're not going to run out of memory. We can just leak everything. It's fine. So arena. Okay, cool. Let's make an arena. Arena alloc. Okay, sure. So does arena alloc allocate something on the arena, or does it allocate the arena itself? Raw pointer, runtime allocator. Okay. This is good. I'm guessing you have to pass it an alignment, but it has a default. You pass it a size. Okay. So you pass it an arena and you pass it a size. How do I get a new arena? Is there an easy way to get a new arena? Dynamic arena. Init. Okay, there we go. But I don't even need the dynamic arena. I can just arena init probably. Arena init. Yeah, that's exactly what I want. And it inits on some data section, but that's fine. We can just arena colon equals arena init. And this is what? Mem dot arena init. And then we need core mem. Something like that. Wait, what? Initializes the arena A. Okay, how do I declare a zeroed struct then? Can you do that? Oh yeah, I can just say, I can do what I did with that thing. I can say like arena colon arena, or like mem dot arena, and then we can just say mem dot arena init arena with how do I just stack allocate like a massive array? Arrays and slices. Yeah, can I just do that? Can I just say like 20, 48, actually I might need more than that. Let's do 40, 96. U8. Does that work? No, so let's just make block 4096 U8. And pass block. Cannot assign a type to variable block. Okay, so you have to do that. Cannot assign value of type arena to arena, so I have to pass it by reference maybe. Yes, and I also need to pass this by reference, I think. No, cannot assign value. Odin arena allocator. Okay, let's see. Okay, so that's how you do it. Arena mem equals make. What the fuck is make? Is this C++, bro? Ah. Okay, that's fine. Yeah, we'll make it 1 megabyte. And then we init it on arena mem. And then arena alloc. What? What is this shit? Bro, what is all this setup just to get an allocator? Like a simple allocator. It's so much work. I mean, obviously in C it's more, but like, really? It's kind of yucky. I cannot say I'm a big fan. So here, where we have digit new? What? What is this new? What? Odin new keyword or function. What? Pointer colon equals new int. Okay, so I can probably say digit colon equals new digit, and then digit dot value equals value, right? Okay. And then we assign the digit, we push back the digit dot node. Okay. That is not the way I like to have my C stuff. I'd rather it be much simpler than this, but alright. I do understand exactly what's happening. It is simple in a way, but it's just not the way that I would do this really at all. Like I do, there's a C technique. I'll show you guys real quick. This is a random project, but if we go in here and look at, like, util probably has some good stuff doing this. So if we go down, you can probably find like, where's a temp? This is the declaration of how temp works. Not really much in here. I know OS has it for sure. So like here, for example, this is how I do an arena. So we have this that returns this, and then we have scratch. And what this does is this is accessing a global that's local per thread, and then it gives you an arena which you do not allocate. This doesn't allocate anything necessarily. These arenas are, there's n per thread, and these are pre-allocated, and the arguments here or to avoid conflicts. So you pass these so that you can pass an arena that you already have. Let's see if I can find an example of that. Probably I can. So here, for example, this already takes an arena as an argument because it allocates something that the function returns. But it also allocates a scratch arena, which is going to get discarded at the end of the function. And to allocate the scratch arena, you tell it that there is an arena, there is one arena, which is, here's a pointer to a list of arenas, or in this case, just one. And this will avoid all of those issues of conflicts. And then you just have an arena, and then you can just allocate on the arena, and then you destroy the arena, and then you return. And this just ensures no loss, and there's 0 actual allocations happening in this function. Unless the only thing is if the arena runs out of memory in this function, all of the arenas here are dynamic. So if you run out of memory on this arena, it will just allocate new memory using mmap or virtual alloc on Windows. And it's that simple. And like obviously the implementation of this is a little bit complicated, but the user interface is so brain dead simple, and you can use it to just make all of your code manual memory management, and it's basically, you don't even have to think about it. There's very little thinking, at least. But I don't really like all of this to do the same thing, and I still have to free stuff at the end too, which is crazy. And probably you have to free like the memory of the arena separately from the block and things like that. I mean, in this case, it's stack allocated, I guess. Although make, I have no idea if that stack allocates. I'm not going to worry about it right now, but I think there's just too much going on with this implementation from a user side for it to make manual memory management super easy and appealing, which probably isn't the main goal, maybe, of the Odin language, but I'm not really sure. Now we do have this list that we're pushing back. Can we just print line the list? No. Oh, yeah. Well, print line L. So yes, we can. But obviously that's not that useful because it just prints us the whole structure, which is the list, which is just a linked list object with pointers. But still good to know that we actually have real memory, and it's not all nil. Well, it could be use after free. I don't think so though. I think it's fine. Like this pointer gets lost, but that's okay because who cares? Also, is this still... Interesting. Okay. Not really sure what's going on there, but okay, so now we have 12 in here. So else, if we're past the first 12, we also have to store which one is the min. Right. And we have to calculate the new min every time, right? Yeah, that's a little bit annoying. With this approach, yeah, we're gonna have to recalculate the minimum. Is there just a min function on list? Because I don't really care about it being slow. If so, like, it's fine. I'd have to think about this more to figure out a better solution though, but no, there's pretty much no minimum. There's an iterator over it. I don't know if I like this solution now. What was my other solution? I kind of forget. It was, well, I had the idea of a sparse array. Is the sparse array better? I mean, let's see. What if we say... Let's do something a little bit weirder, actually. Oh, it was position array pairs in a sorted structure. Okay, I'm thinking... So there's a few different things we could do. One that I'm thinking of is, I mean, this feels annoying in this language. Like, in C, I could do this in no brainer. There's just too much crap here. Like, I was thinking that I want a 10 value array, like 10 distinct values, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then in that array, you index in, and each index is a pointer to like a pool of pairs where it's index in the big number, and yeah, I don't know. No, it doesn't make any sense. How about we do this? So we do this, we push into here, right? No, that doesn't make any sense. There's no way to avoid like having to calculate the minimum on every single iteration, which just feels bad. Like that doesn't feel like work that we have to do to solve the problem. This is obviously not how you solve it fast. Like the way you solve this problem fast is that you ignore that and then you just write the dumb solution. But I want to solve this problem good, which means that I need to do something different, at least. I need to think about it a little bit. So we need to get the 12 largest numbers from an array. That's pretty easy, actually. We just push it. Okay. What if the doubly linked list is always sorted? Which we can do by pushing based on the head and the tail. We can say, is this greater than or less than? Is this greater than the head or less than the tail? And but then we have to iterate through, and like if something needs to go in the middle. And there are structures which we can guarantee are sorted, but they're all really annoying. Topological sort. What is the structure? A generic OVE topological sorter. What are you talking about? Okay, this is a key value pair, which is kind of what I'm thinking of, like with the 0 through 10 solution, but it doesn't really make sense. I don't know. So we push in the first 12. I think that makes sense. And we can have a minimum. But the problem is, as soon as we switch out the minimum for something bigger than it, we don't know what the new minimum is. We need a sorted list. Yeah. So and this list doesn't have like any procedures for doing that kind of stuff. No. Like, I don't know. I feel like this language could be very strong. I like the philosophy behind it. Like, my favorite thing about the Odin language is that part of the philosophy is that there's no package manager or like a million package dependencies, but the standard library is broadly encompassing, so you don't need dependencies, which you can see clearly. Like, it has like SHA calculations and like ED25519 hash implementations in the standard library. Very much like something like Java or C#, which also has like everything in its standard library. There's even like a net which provides at least sockets. I'm not sure if this provides like an HTTP server, which I know like, but like it's strange because sure I agree with this, but like a language like Zig or Rust, which do have package managers, and that kind of annoys me. I don't want to have dependencies, but their standard libraries are also more encompassing. Like Zig's standard library has an entire HTTP server in it, for example. And maybe Odin wants to have that at some point, but it's just not there yet, as far as I'm concerned. At least from this test, like, even though you wouldn't really want to sort a linked list in most of the cases, I don't see any way in which, like, I could easily do operations on this linked list besides iterating over it and just doing things myself. Which that drives me to go look for a library that has a bunch of those things built in, because I think there's only 10 or 20 things that I'd ever actually want to do on a linked list, and I'm not going to want that much power to customize it. And so I would look for a library that handles linked lists better than the standard library, but the whole point of this language is that I shouldn't feel like that, I feel like, but a little bit sad. I do not know exactly what I'm going to do. I'm going to keep trying to think on the problem. Maybe there's something obvious I'm missing. So 98765432111 2 3 4 2 3 4 2 3 4 2 3 4 2 7 8. Okay, I'm gonna be stupid right now and say min equals 10 for num in L for num in L if num is less than min if statements don't actually have parentheses around them. That's what I was just checking. I mean, obviously you can have them, but min equals num. There's probably a shorter way to write this too. You can probably do some kind of ternary thing, but I'm not that worried about it. Equals if, alright, what, there must be like, I feel like there's probably something like min equals num if num greater, like if num less than min else min, or something like that. But I'm not gonna worry about it. This is stupid code how I like it, and it probably will work. What are we doing next? So we have the min, we're just gonna full calculate the min. Really boring, big waste of time. Say no more, that's fine. Oh, also, we have to dot value all of these because num is actually of type digit. Okay, so we have that all sorted. I don't know what I'm doing, so well, now we have the min, so we can just do what we were doing before. So we can just say okay, we have the minimum, and we also need the index of the minimum. So maybe like min node colon equals, or list dot node or something, and then say like min node equals num dot node. Or even better, even better, we can say this is a digit of value equals 0. And then we can say if it's less than min dot value, and actually 10, then min dot and min dot node equals num dot node. Or even better, min equals num. So now we have the location and the, yeah. So then we can say oh, that's weird. If min has num's node, cannot iterator. What? There's literally an iterator. Or do you have to dot iterate or something? I mean, that's not a thing. Hello? The iterator. Iterate from node. Iterate from ahead. Okay, let's do that. Iterator ahead of that, and it's going to be list dot lowercase list. Type parameter t is missing in the procedure call. Parameter field name of type string is missing in the procedure call. Didn't have a default. Okay, whatever. Iterate over value. Cannot iterate over I don't understand this. For an example, see iterator next. Okay. List.iterator hell my next struct node. Oh, it's the name of the, okay, yeah. Oh, is it? In list.iterate next. Oh, okay. It equals the list dot or digit iterator hell and then this kind of sucks. Well, maybe see, is there a way to replace Can remove by proc. So yeah, you pass a node when you remove something. Okay, that should work because the node in this should be the same node that's in this by value, or some unique identifier that I just copied, right? Surely, cope. Yeah. So that works now. What are we doing? So this actually sucks. Next up we have, so we finally have the minimum. That took a while. And now we're going to say if a value is less than min.value, or if it's greater than, right? If it is greater than that, so if the current value we're looking at is greater than the minimum value in our list, then remove list.remove L, and we're removing node min.node, and then we are going to push list.push who the hell cares front. That's fine. And we're going to push onto the front value, which is going to be a new, or digit even. Isn't that crazy? We'll even say digit.value here. We'll push front digit. And then we're going to sum it. So sum equals 0 for, dude, fuck this stupid iterator shit. For num in, for val in, we'll call it num again. Okay. Cannot assign value L of type list to list. Yes, I did mean reference to L. And I'm guessing this also wants a reference. Yes, and this also wants a reference to this. And this also wants a reference to that. Oh, never mind. Wait, what? Oh, it wants digit dot node. Zero. Are you kidding? What? But the final joltage is 0. What? Joltage plus equals, right? Or am I crazy? What? No, that's insane. First of all, are we even getting close to the right thing? That's the first question. So, for example, is 44 the correct final one? No, it's not even close, right? Because this doesn't actually help. Because a digit must also include its index, which is going to be an int. Right, and the index of a digit dude, this sucks. This is such a bad solution. How do I make it better? Ugh. I might give up just because it's so ugly. I won't give up. But like, geez, this sucks. Like, hello? So it would literally be easier if I just... That's a little bit funny. Screw it, we're doing that. Get all this crap out of here. We're gonna do something way better. And really stupid. But I think way better. Which is... No, we don't need this list either. We don't need this. We do still want the value. Sorry, surely we will want that. Okay, so we're gonna do something really, really dumb. Watch this. Values left. 12. Here you go. If values left is 0, break. Like that, right? If we have 0 values left, we break. Obviously, I couldn't code that in the for loop, but whatever. Then, check val is 10 or is 9. Watch this. Found equals 0. Okay, watch this. Values left is 0. We break. If value is check val, if value is check val, this doesn't solve that though. I'm getting rid of this. Although, I think this is an okay idea, but I was gonna do something really stupid, which is I was gonna iterate and check for every single 9, then check for every single 8, then check for every single 7 until we found 12 things. But that doesn't actually tell you how to order them. So let's do some kind of stack. I think the stack is probably the next best solution, is that we have a stack. I mean, I really want, like, this is solved by a particular type of data structure, right? And, like, the language just doesn't have that type of data structure. Like, it's not that kind of language. So this is really disgusting. AVL trees. This is an AVL tree. Is this exactly what I want? Self-balancing binary search tree. Bro, This is like exactly what I want, right? Self-balancing binary church tree. The heights differ by at most 1. See, the problem is, like, this doesn't, anything like that reorders the data set, and then you don't know how to construct the number. Maybe I should go back to the digits and stuff, because maybe that's unavoidable. But like in the first solution, it was very simple. We just looked at that, and then... So we can probably do the same naive thing. And just store 12 different maxes, right? Like, I mean, why can't... What's stopping us from doing part 1 solution, but with 12, with max 2, max 3, max 4, max 5, through max 12, or max 11, or max 12, yeah. What's stopping us from doing that? So what do we actually do with max? So if we find... Yeah, and we have to do this. So if we find a new... Yeah, what am I even thinking? The solution that I had wouldn't have worked at all anyway. If we find a new, like, first max in the first digit, it resets all of the ones after it to look again. Yeah, okay, so what we actually want to do... Okay, this is actually quite easy now. We have size, and then we have digits, which is an array of int size 10, or size 12 int. Right, so we have digits in a line, and so we have digits in a line. We have 12 digits in this array, and we loop through. And on each thing, we get the value again. I don't know why I keep deleting it. We're obviously going to need this line every single time. We're always going to need the value as an integer. And we're going to say, so this should be 0. This is 0 initialized. I'm 99% sure this language is 0. Let's see, where is it? Uninitialized variables are 0 initialized. So we don't have to worry about that. We have 12 zeros. And we're going to say the value int equals blah, blah, blah. And now we're going to loop over, and we're going to say if, and this is a big if. So we need to check basically this case, but for each slot, right? So we're going to for loop over. So we're going to do for digit in digits if I, so if I is less than, and I want to look at my part 1 solution while I'm doing this so I don't mess up a logic error. If I is less than the length of line minus 12 minus digit, or this doesn't really work, but we can say for k in 0 through 12, or 0 through 11 even, or 0 less than 12, that's actually what we want. So if I is less than this minus k, so 12 minus k will be 1 at the end. So that's wrong, so we want 11 minus k, I think. So this is gonna mean, or do we want 12 because we want 12 because line 1 is off by 1 anyway. There might be some off by 1 errors here, let's see. So if I is, like, we're looking at the 5th letter in a 4-letter sequence, or in a 6-letter sequence, and it's like 3 or something. or whatever, that doesn't make any sense, but let's roll with it. So the length of the line is like 6 minus 12 minus k. So 12th digit, the 11th digit, down to the 1th digit. No, so it is 11 because the 0th digit is actually the last one. Because we're less than. If it was less than equal to, then we would do 12. But this is fine for now. And we're even going to do another layer of parentheses just to make this extra super explicit. So if that is true, and value is greater than the max or whatever, or the current value, right? That's actually like if it's greater than the digits at k, then digits at k is now value. And we break. Say we're short-circuiting. This digit has been used. But before we break, we go 4 L this is really stupid. K plus 1 L less than 12 L plus plus digits at L equals 0. So we're resetting. Oh my god. You motherfucker. I really don't like people removing the postfix operator from everything. Okay. Now, let's fmt dot print line digits. Okay. Did we actually get something real? So 434 434 234 234 278. I think we have it. That took way longer than it should have. 8889111 Oh my god. Okay. We are so back. That took way longer than it should have. Honestly, pretty fine now that we have it. Any unused variables? Like, no, I don't think so. It's totally fine. So we're not going to print digits. We have to do 4 I in digits. Let's see, this is like battery equals 0. Or, I mean, we can just add it directly to joltage. So we can just do 4 I in digits, joltage plus equals... No, this is so dumb. 4 I in 0 dot dot 12 less than 12. Voltage, joltage plus equals, and this is gonna be like, what, is there an exponent operator built in? Cast operator, transmute operators. There is no power operator. That's fine, we don't really need this. It's just gonna be like I times, I mean this should all be like comp time or whatever, right? In theory. But I'm not sure how you would do this at compile time. Like, I mean, all of the multiples of 10 could be calculated at compile time somehow with this loop, and it would be like some kind of function call. If that were easy to do. I don't think that that's easy in this language, to be honest. And it doesn't really matter that much, to be honest. The performance of this is going to be negligible. Let's add, so we want 12 minus I is the position, or 11 minus I. Like, what's the, is there a math library? There's probably a math library or something. Math. POW. POW 10. There's no documentation. Hello? Can I get a version of this that's like nice? I don't know. Exponent? The entire math library is only floats. Which makes sense if you're actually trying to do math, but like I just want. Alright, fine. We'll unroll it because we're epic like that. Here you go. Digits at 12 or at 11 times so this would be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. How do you do so G capital A, or is it? It's like no, it's Control G. Wait, what? Am I stupid? Yeah. It's G control. Yeah, it's this. Sorry, I'm having a Vim moment. So that's how you can get them to increment. Is there a way to get them to decrement? Increment, decrement is Control X. Okay, yes, you can. Let's revert back and let's G Control X. Oh, beautiful. Exactly what I wanted. That took way less time than typing it manually. Epic Vim moment, so true. All right, let's align all of them and then let's do this. There's probably a cool Vim way to make a pyramid out of this too. Okay, and this is on test, right? Okay. And it's wrong. Well, isn't that lovely? Is it wrong by an order of magnitude? Or is it wrong by something else? Like that? Is that the same? Yeah, it's like a full order of magnitude too low. Am I doing this calculation wrong? Because I actually calculated I got all the right numbers, right? FMT print line digits. Sorry. Part 2. So we got 98765, 9876543211111. We got 81111119. We got 4342342342778, And we got 888911112111. Yeah, we got all of those. So that means that we clearly did something stupid here. And I can't do basic math, apparently. Are we skipping? Yeah, we're skipping a digit. Of course we are. We're skipping digit 0 because I'm brain dead. That's why we started on 11, because there's a 0 with. And this one is now times 10. This one is times that. Okay, this calls for a macro. QW find right paren, insert mode, insert a 0, up Q at W, 5 at W. There we go. No, why did it go up twice? That didn't change our answer at all, apparently. What is going on? Is it not? Sorry? Did that really not change my solution? Like what? Hello? 12 is out of bounds, right? Yes. Like very clearly. So the first digit is times nothing. Yeah, then that digit is times 10, times 100, times 1,000, times 10,000, 10 times, etc., etc. Okay. Maybe we should string parse it instead then. I mean, that's just like worse though, objectively, than doing this math solution, right? Or am I crazy? I'm so dumb. I'm so stupid. I don't know why I thought I was decrementing this. And I don't know why I just did that, but luckily we did just learn the solution to fix this actually, which is, what, it was Control X on these? Yeah, there we go. Why did I think it was that? Okay, that looks right. I don't think we have any logic errors. I think we can just run this. I'm gonna leave a comment like, sadly, couldn't find a simple way to do this with Odin. All math exponent functions expect float, and that's annoying. There we go. So we're doing the lovely, the loveliest solution, of course. Oh wait, not lovely if we have that right there. Okay, beautiful alignment. Cool, I suppose. Yeah, okay. And let's try it on the real inputs. I was about to be like, oh, we're done. But no, I haven't actually run this. If this is wrong, I'd be really mad. Okay. We are right. That was not too bad. It was a little bit bad, but not too bad, I would say. And we've completed day 3. So we're one step closer. Let's make sure. I think I forgot to remove Odin from the list. Oh, why did I do that? This has everything in it. Did I remove, like, no. I will spell elixir right this time though. There we go. Incredible. So that's that, and we're done. All right. Let me add this to Git real quick. And git commit day 3. Awesome. All right, I will see you guys tomorrow.